Hello everyone and welcome. My name is Ashish Dubey and today we are going to be diving into the fascinating world of social network mining. Specifically, we will be exploring how we can use advanced data analysis to extract powerful and often hidden insights from the digital social fabric that connects billions of people around the world. So to begin, why should we focus on this field? Social networks like Facebook, Twitter, Instagram, and LinkedIn are no longer just simple tools for communication. They have fundamentally transformed how we share information and form communities. The key takeaway is the sheer scale. These platforms generate absolutely massive amounts of data every single second. This data explosion has created an unprecedented opportunity for analysis and insight. As a result, social network mining has emerged as a critical field across many different domains. In marketing, it's used to highlight highly specific consumer targeting and to measure brand influence. In sociology, it gives researchers a new lens to understand complex social behaviors and track emerging cultural trends. In in politics, it's a core tool for campaign strategy and for performing real time sentiment analysis on public opinion. And in public health, it's even used to model how diseases spread and to understand public health behavior like discussions around vaccination. So, let's establish a clear definition. Social network mining is the formal process of extracting meaningful patterns, insights, and knowledge from social network data. It does this by using advanced computational algorithms and a wide range of analytical techniques. The key components are simple to understand. First, we represent individuals or other entities as nodes in the network. Second, the social interactions or relationships between them are represented as edges. And third, the mining itself is the process of applying computational analysis to these nodes and edges to discover patterns. Now, you may have heard of social network analysis or SNA. It's important to understand the distinction. SNA analysis typically focuses on understanding the existing relationships and the static structure of the network. SNM mining goes to a critical step deeper. It applies machine learning and data mining algorithms to this data to uncover hidden patterns and, most importantly, to make predictive insights. When we talk about social network data, we are really talking about two primary types. The first is structural data. This is the architecture of the network itself, the skeleton. It answers the questions who is connected to whom and what is the strength or property of that relationship. This data forms the literal backbone of our analysis. The second is content data. This is the information that actually flows through those connections. This includes all the posts, tweets, comments, messages, and multimedia that people share. This data is what reveals what people are actually discussing and sharing with each other. To make sense of all this structural data, we rely on a powerful and elegant mathematical framework, graph theory. As you see in the visual, a social network can be represented as a graph. In this graph model, individual users share or entities are the nodes and the relationships or interactions between them are the edges. We can even assign properties to them like a user's age on a node or a timestamp on an edge. This graph representation is what allows us to apply sophisticated algorithms to find patterns. One of the first and most important things we can measure is centrality, which helps us identify the most influential or important nodes in the network. But importance can mean different things, so we use different metrics. First, there's degree centrality. This is the simplest. It's just the number of direct connections a node has. Think of a social butterfly. This person has a very high degree centrality. Second, betweenness centrality. This one is fascinating. It measures how often a node acts as a bridge along the shortest path between two other nodes. These individuals are critical connectors. They might not know the most people, but they are but they connect different, otherwise separate parts of the network. And third, closeness centrality. This measures on average how close a node is to all other nodes in the network. A node with high closeness can spread information to everyone else in the network very quickly. And now let's talk about the advanced mining techniques. Beyond centrality, we get into more advanced mining techniques. First is community detection. This is essentially an automated way to find case or subcultures. It uses algorithms to identify clusters of nodes that are much more densely connected to each other than they are to the rest of the network. Algorithms like the Lovian method or the Girvan-Newman are used to find these natural groupings. Next is link prediction. This is a predictive task that asks what new connections are likely to form in the future. By looking at the current network structure and node attributes like common neighbors, machine learning classifiers can predict the likelihood of a new friendship or follow. This is the magic behind people you may know suggestions. Finally, we have influence propagation. This is all about modeling how information, behaviors, or even trends spread through the network from node to node. By understanding this, we can identify key influencers and run simulations to find the best way to make a message go viral, a process known as influence maximization. Now let's talk about the real world applications. So let's tie this all back to the real world. How is this being used today? In marketing and business intelligence, companies use this to identify their most influential brand ambassadors, understand consumer preferences at scale, and even predict product adoption patterns across different demographics. In public health, organizations use network analysis to track disease spread patterns, understand public attitudes toward health policies, and design highly targeted intervention campaigns. In public political campaign strategy, these techniques are used for precise voter targeting, performing real-time sentiment analysis of public opinion, and identifying key opinion leaders in specific districts to help optimize a campaign's message. And in fraud detection and security, platforms analyze network anomalies to identify fraudulent accounts, detect coordinated bot behavior, and recognize suspicious transaction patterns to protect users from scams. Okay, now let's talk about challenges and considerations. Now, as powerful as this field is, it is not without its very significant challenges. The first is scalability. Modern social networks are enormous. With billions of users and trillions of connections, analyzing a graph of this size is a massive computational hurdle that requires sophisticated distributed computing and highly optimized algorithms. The second is data quality. Social network data is inherently noisy. It's filled with missing values, fake accounts, bots, and inconsistencies. Poor data quality will lead to incorrect insights and flawed decisions. So robust data cleaning is absolutely essential. Finally, and most importantly, privacy and ethics. We are mining personal data about human behavior. This raises serious ethical concerns about consent, surveillance, and the potential for misuse. Balancing the analytical value of this data with the fundamental right to user privacy is perhaps the single most critical challenge facing this field today. To conclude, what does the future hold? The field is constantly evolving. We are seeing several emerging trends. First, decentralized networks. New blockchain-based social platforms will require entirely new mining approaches that can work while preserving user privacy by design. Second, new platform dynamics. The rise of platforms like TikTok and Discord, which have very different structures, present fresh opportunities to understand how social behaviors are changing. And of course, AI integration, advanced deep learning and natural language processing NLP are dramatically improving our ability to recognize complex patterns and make more accurate predictions from all this data. Second, new platform dynamics. The rise of platforms like TikTok and Discord, which have very different structures, present fresh opportunity to understand how social behaviors are changing. As our world continues to get smaller and more connected, the social network mining will remain an essential tool for understanding human behavior, predicting trends, and making data-driven decisions. Thank you.